to speak, and I'd really like to thank Brian for his support today and that of HCI Viocare, who's helped make this event possible. Brian's going to be speaking on options for prosthesis and orthosis, selection, choices in shape, materials and components. And welcome to the podium, Brian.
Thank you. Thank you, Sandy. I just want to thank Sandy and Porter for inviting us along to this event. As you can see, we've got a stand as well for our clinic that's still relatively new. If you get any questions regarding the clinic, come and ask myself or George. We'll be happy to answer during lunch or later on. As Sandy says, I'm going to be talking briefly, because it's coming up to lunch and we're all probably quite hungry, about the choice in shape, materials and components available just now in prosthetics and orthotics. It's going to be a very brief review. Any questions about it, then you can ask me later. So as was being discussed earlier on, three most important factors as far as I'm concerned is appearance, comfort and function. Everyone is very different, so each thing is different to each person. Some people just want something that looks very lifelike. Other people want things that are just, no, I need it to be able to do things I need to do. Or people just want to be in comfort. As we said about the different triangles, I think that's a very good new way of doing it. And I think Alan's app will be a great little thing, because I think it'll be really interesting to see what people say about different things. I'm here to do that for any person. Whatever they want the most, we try and achieve that. Other processes involved, of course, with manufacturing, user preference, they're at technical level, and sometimes, now that I'm in the murky world of private, it's cost. So how do we go about this? I've got two helpful volunteers in the middle there, the two girls. They come in quite handy sometimes. We have many ways of taking impressions, casts, measures, scanning. How we go about that is sometimes down to the clinician themselves, their experience, their preference, what they've got access to. And you can see we've got a scanner there that some people like to use. My youngest, Jasmine, she's next to an alginate cast to be used for impressions for silicon. Impression box for insoles, people think, well, that's 50 years old, works, does a good job and it's quick and it's reliable. And that's myself casting it and above me MP3 as well, all different methods that we can use. First of all, we've got the shape. Transfemoral socket design has changed somewhat over the last 50, 60 years. Again, it's down to user choice, what works for them. Is there any problems with it? We'll look at a different method. Usually, if someone's got something that works, they don't really want to change how that goes about. We start off with quad designs, ischial containments, marbles, sockets, hi-fi, infinite sockets, hybrids, hundreds and hundreds and hundreds of different socket designs out there now. How you get to, as users, how do you get access to that? Well, again, it's usually down to the clinician's experience or the limb centre's ability to have the materials. Same for transtibial, you've got supracondylar, patellar tendon bearing sockets, total surface bearing sockets, and now we've got more and more adjustable sockets. I noticed on the steeper stand, we've got adjustable socket for, they've got the products available to be able to do that. Again, there's a cost and everything else, implication of time. NHS struggles for time for the patients as it is, so we have to make sure that we can work that into current services. For hip disarticulation, again, we used to have the top right, depends what you're looking at. That was kind of one of the more conventional ways of doing hip disc, quite heavy, bulky, painful sometimes at times, but it worked. And then in the middle, kind of more advanced technology, and a bit less of a socket, more modern components. And then to the bottom there, you've got a Martin's Bionic bikini socket. I didn't name it. That's what they call it, and you can see there how little there is with regards to an actual socket. It can help improve temperature and everything within the socket, improve mobility because it frees up the other joints as well to do what they need to do. Again, loads and loads of different shapes and designs out there for people to try and access, and it's up to us as clinicians to try and figure out what's best for each person. Not going to leave out orthotics. We've got the shape with orthotics as well. We've got a knee, ankle, foot orthosis, ring top orthosis, which we've got down at the bottom there. Doesn't look like much, but it works for a lot of people. Doesn't look very comfortable, but it's comfortable for a lot of people too. In the middle there, we've got a corset. Again, it's good when people have volume fluctuations. We touched on that earlier. You can loosen and tighten that as you go. Again, looks very old-fashioned, but there's still people out there who need that, so there has to be the facilities still available to do leather stuff, which is dying trade. Metalwork is a dying trade as well in our profession, unfortunately. To the right, we've got a CAFO there that Sandy may recognise.
I was going to bring it and I forgot.
And someone else might recognise the leg, but I won't say who. And then down towards, we talked a little bit about more advanced technology. There's a EMAG pre-preg sort CAFO. Pre-preg is another manufacturing process. We'll discuss it a bit later on. For EFOs, all different shapes and designs. We've got PLSs, we've got standard EFOs, dynamic EFOs, conventional, SAFOs, which is silicon one with dorsal do, which is fantastic. Again, we have to work all these into what does the user need, what is their priority when it comes to function, appearance, or is it just how comfortable it is. We have to take that into account for everyone, which is why we have to treat every person as an individual. Prosthetics again, components, hundreds and hundreds and hundreds and hundreds of components out there. How do we know about them all? Well, we don't, to be honest. We don't. There's no way we can know about every component that's out there. What we have to do as clinicians is make sure we go to events like these. We've got our own conferences, there's ISPO, there's BAPO, there's all different conferences. We go to updates in technologies, companies come round to us, companies that are based in the UK are all very good at giving us updates on the components so that we have the best access as possible to what's out there. Again, there's restrictions, there's lots of talk about microprocessor controlled knees, both in Scotland and certainly down south just now as well. Unfortunately, there's a bit of a postcode lottery about whether they do that. I'm in the private sector, so I can't say too much about that. So I won't get involved in too much about the discussions there. But there's the Genium, as most people have heard of, X3, Nevo, C-Leg, all from Autobot, Rio knees, Orion knee, Link system, both from Blatchford's, and there's a Play, to name but a few. There are many, many more out there. And as clinicians, we need to make sure that we have the best available knowledge on these to give it then to the patient. What I would stress is that no matter how much I know about these components, the user can tell me what is best for them. And the only way to do that is to trial these things. All the companies will allow you to trial stuff. All the companies will. Osser, Blatchford, Steepers, Autobot, any of the other companies that I've used will always allow me to do at least a 2-week trial. At least a 2-week trial. Again, there's more and more talk about microprocessor controlled feet and ankles, Biome, which is now involved with Autobot. There's a line from Blatchford's, Osser's Proprio Foot, and the Triton Smart Ankle and Meridian from Autobot. Again, this is to name quite a few. We need to know a wee bit more about them so that we can then advise what might be best for the user. But again, they're all there to trial. Many more feet and knees available, hydraulic knees, hydraulic ankles, everything that you can imagine that's out there, we have to try and access it. So you've got hydraulic ankles like the Quintera and Avalon and Echelon feet. General feet, as we're calling them now, which used to be the more sophisticated feet like carbon fibre feet, from Osser, Autobot, Blatchford's, etc. are all out there. Then you add in, what if I want a water activity lift? That adds another thing into the mix because a lot of the components before aren't waterproof. Again, we have to look at what the user wants. Multi-articulating hand, you saw the B-Bionic briefly, which is over at Steepers counter. You've got we've been allowed to borrow an island from Touch Bionics, that's on our stand. And there's Michelangelo from Autobot. Again, this is to name but a few. From then, you've also got just the more standard myoelectric hands that are just the pincer grip that most people require. Moving on from there, in prosthetics, you've got people's hobbies and sports that we also have to take into account. I know when I was working from the NHS, it's more and more difficult to supply things for people's hobbies because they're not going to be using these limbs every day. Is there a justification in the cost for allowing someone to use something once a week? That's not for me to decide, thankfully, anymore, and I think that's difficult to answer that question. We just see a couple of examples there. We've got the blades, we've got the Pro Car from Autobot, Bartlett tending, which is good for people who want to go mountain biking, and I think that's the early ankle extended on the bottom. More from prosthetics, we've got elevated vacuum, we've got liners, we've got all kinds of things that we as clinicians have to have some knowledge about so that we can give the user the best information available to help them decide in that situation. I very much think that the interaction between the user and the clinician is a two-way process. I hear a lot of conversations from users that say, I just feel like I'm being dictated to and told what I need to do. I don't think that needs to be the case. I don't think it has to be the case no matter what the budget restrictions are. I think it's always a two-way process. But in orthotics, there's many devices coming out there, and there's more and more coming along. For CAFOs, you've got the EMAG and the FreeWalk and the C-brace, microprocessor knee and a CAFO. You've got titanium, the use of offset knee components, all kinds of things out there. Again, the most important part is that initial assessment of the user. Find out what the requirements are, find out what their needs are, and take it from there. What kind of mobility do they want to achieve? I think was mentioned earlier as well. More and more orthotics, as I say, is very brief overview. We've got dynamic AFOs, we've got PLSs, we've got Intrepid dynamic exoskeletal orthoses, which I can't say very well, so I just got an IDO. Again, they're quite dynamic, fairly new, I think, as far as I'm concerned. Simple things like heel cups, all different things available. We need to know what's the best for the user. Shoes, footwear, semi-bespoke, totally bespoke, whatever it is, has to be right for the user, and that interaction has to be correct. Then it's materials. Goodness me, how many materials are used in prosthetics and orthotics? I have no idea, and I'm not going to list them all here. Carbon fibre, heavily involved in prosthetics and orthotics. Gives good strength, lightweight, can be costly. That's an argument that you could have. Pre-preg technology allows less wastage, can be lighter, can be stronger, but you need to have certain ovens for that kind of thing as well. Pre-preg is basically carbon fibre that's impregnated already, and then there's a curing process in an oven that allows it to set. You can actually cut what you need and just use what you need rather than all the excess cut off you would have with a more standard lamination. The use of silicone has come on leaps and bounds even in the last 10 years. It's durable, can be discreet, usually relatively comfortable, realistic if you want it to be. Can be heavy depending on what it's used for, and there's quite a significant cost with most silicone, whether it be a liner, silicone foot, or even the SAFO as I mentioned earlier. These are all relatively expensive, but again, if it works, it does last quite well. Loads and loads of plastics, loads of plastics. I'm not a materials expert, I'm not going to go in depth with that at all. But some of the materials that we use is homopolymer. It can be strong but brittle. As soon as you get a little crack in it, it will fail. You have to weigh that up with some orthotic devices especially. Copolymers is a good plastic because there's a bit more flexibility involved in it. Northplex is something we use quite a lot. As Alan mentioned, I still do the old-fashioned method. I do check sockets made out of Northplex. Can't use it outside though, so we need to make sure that we're doing the right thing with that. Northvein is strong and flexible. C-Flex is very flexible as well. And again, this is just to name but a few. And there's some gratuitous advertising going on down there as well, notice. I purposely put those there. And as I say, there's loads of other materials, titanium, steel, aluminium, lamination materials, leather for shoes, corsets, sockets. All of the above can be used in one device. And it's up to us as clinicians to work very well with our technicians to make sure that we are giving the best stuff to the user and that everybody is up to speed with the manufacturing process. And George, our technician, is taking his life in his hands there when my daughter's trying to hit. That's a cat collar, believe it or not. It's not something we do that often in the clinic, but it was bring your daughter to work day, I think, that day. And even tartan. We can even make things out of tartan. I should say this is a laminated socket. It's a hard socket with tartan over the top of it. And we did that just for burns earlier on this year. As I say, it's a really brief overview, and I've kind of rushed through it a bit, conscious of the time. There's so many materials out there, there's so many components out there, there's so many things that we can do to help improve all that. And it's up to us to make sure that we continuously, we're always doing professional development, it's called, we have to do it. And that's to give the user the best stuff available, but it has to be a two-way process. I'm going to reiterate that. It has to be a conversation. What's going to happen in the future? As Alan said, 3D printing is there. It's not the future, it's here and it's available. I'm a wee bit old-fashioned, I prefer casting, but I do agree for some areas with the reduction in time and the financial constraints in a lot of areas, sometimes in the UK but certainly worldwide. I think 3D printing is a fantastic way of going about it. You can actually get titanium now printed, you can get carbon fibre printed, all kinds of things printing now, and all kinds of designs. Direct skeletal attachment, it's not a new thing. It came back and it's coming back more and more. I think that's you're going to see more and more of that available. Hopefully, as far as I'm concerned, that can become more available in the UK for NHS, because I think the benefits from it for the right person are quite immense. Mind control, no Terminator stuff. Again, that's something that's going to come more and more in the future. I think those that were here last year, there was a chap from OSA who could mind control his ankle, and he could put it down, but coming up, forget his name now, that chap. Very interesting guy. That's the one. Thank you, Sandy. And as part of the muscle gain innovation, where Sandy was pressing the myoelectrodes in one of the hands, they can get direct onto your muscle vellus, so you can contract your muscle and that can operate the device. I've been using upper limb just now, and I think it's going to improve lower limb as well. And that's about it, I think. I've got a wee video here that I was going to put on. I was going to put some Benny Hill music on in the background.
Right, we'll have to sing it. What was the Benny Hill?
And as I say, I know we're a bit pushed for time. If anyone does have any questions, you can just ask me at the stand. I'll be around. Any material stuff or any of the technician stuff, you can ask your technician, George. Okay.